All right. Everything that we have done up until this point. Now is when it starts getting serious. Okay, not really, but like, I guess here's where it starts getting like mathematical. I guess maybe that's kind of an appropriate way to say it. I guess. So. The tangent ratio. Wait, what? We're doing new stuff? New? I didn't sign up for new. Wait, who said new stuff? No. Actually, let me reassure you that everything that we are about to do from this point forward, like, nothing's really going to change. We're just going to, again, get more mathematical in term, I guess. But let me just reassure you that all the stuff we're going to do, you know how to do it. So don't worry about that. So to recap, you're probably all sick and tired of that. You're like, yeah, I know. We talked about slope ratios. Whenever there's a inside of a right triangle for like an 11-degree angle, I know that if I compare the opposite side versus the adjacent side, it's always going to simplify to 1/5. Got that branded into my brain. Cool. And you probably have 22 is 2/5, and 18 is 1/3, and 45 is 1/1. Sweet! Yeah, you probably got all that down. We've done enough of it, I would hope so. And how to solve mathematically certain problems that come along with knowing these bits of information. Again, we've done a fair amount of this. So like, hey, look, oh, sweet, an 18-degree angle. Well, okay, how do we go about doing that again? Well, first of all, we recognize, an 18-degree angle, I know what the slope ratio is. The slope ratio for an 18-degree angle is always 1/3. It simplifies to that, right? So I might make that note. And of course, we recognize, because we talked about this the other day, our slope ratio really just always compares our opposite side, and we divide it by our adjacent side. Just kind of an easier way so we don't have to rotate triangles and stuff like that. So we just always recognize that, okay, my 18-degree angle is right there. Opposite side is the one that doesn't touch it. And the adjacent side is the leg that does touch it. So opposite over adjacent. Cool. So what we did was we kind of combined everything. We recognized, okay, slope ratio for 18 degrees is 1/3. And a slope ratio is also just the ratio of my opposite side divided by my adjacent side. So we set them equal to one another. Hey! And we cross multiply across an equal sign. And solve. What? Why do I not see them? Something's up. Hold up. Well, whatever. I don't know why this isn't going full screen. Escape. Full screen. Oh no. Oh no. What has happened? Miss Maria, I broke it. Oh well.
I think it was just that your toolbar was up.
Yeah, you're probably right.
When you were presenting.
Yeah, I bet you're right. I don't know why, though. Oh, well, whatever. We'll figure it out. We're not going to do that. So anyway, cool. Hey, everybody. You have a right triangle over here with an 11-degree angle in it. Wow. You should probably know how to solve for R. Take 30 seconds and solve for R. Here's what I want you to do. Hold on, pause. Don't do anything yet. What I'm going to ask you to solve for R. I'm going to ask you to put it in the chat bar what you get for R, but do not press enter. Just put it in the chat bar and just leave it chilling there for a second. I'll tell you when to press enter. You have 30 seconds. Solve for R. Go. There's a timer right there, so I actually know. It's kind of nice. We've passed 30 seconds. Okay, everyone, into the chat. You have not put your answer because it was fine. The Jacquelines, of course you did. My goodness. All right, everyone else, press enter. Chat explosion. I want to see what's going on. Yeah. Woohoo. Ooh, look at there. Woohoo. Woohoo. So much participation. Yay. It's exciting. It's a good yay. Yay. Woo. Cool. Sweet. Nice job, third period. And by the way, I will be taking notes and giving points to people who are participating, so I got you. Nope. Yep. Yeah, exactly. What I'm sure most of us did. Hey, the bar's gone. Sweet. We remembered, hey, an 11-degree angle. That has a slope ratio of 1/5. And of course, the slope ratio is also equivalent to the opposite side over the adjacent side. So we say 1/5 is equal to opposite over adjacent. Well, what is my opposite side and what is my adjacent side over there? Well, opposite is obviously the 6. That's on the far side. It's not being touched. And the adjacent side is the R. So really, the only difference between the first triangle I did and then the one you all just did was just the side we solved for was either on the, it could be in the numerator or it could be in the denominator. That's just something we need to be alert for. That's why we just say opposite over adjacent. Well, you just recognize it. So that's good. So cross multiply across an equal sign, and yes, everyone gets 30, and it has nothing to do with both the Jacqueline's typing it into the to the chat and everyone just copying. You all just did it properly, which is good. Right. No, it's fine. You're good. I don't care. There are much more crazy things to be upset about than just, oh, I put it into the chat. Anyway, so yes, cool, awesome, good job. Guess what? Nothing's changing. Sorry. Nothing mathematical is changing. But just so you know, so we found slope ratio. Okay, we did that. That is in combination with stuff we did from Math 1. You always found the slope ratio of a line because you made slope triangles and all that jazz. But what I think we've recognized is that, okay, I have a right triangle. It's got an 11-degree angle. If I compare the opposite side over the adjacent side, it's always 1/5. And it doesn't matter how big the triangle is because we use similarity and we derived all this. And we just note that it's always just a ratio is just a comparison, and it just always happens. Yeah, this is a naturally occurring phenomenon that happens inside of any type of right triangle. For 11 degrees, your ratio is always going to be 1:5. 22 degrees is always going to be 2:5. 18 is 1:3. Like, all of that is always, it's just naturally occurring. It happens. Great. But, like, in the math world, they came up with a more technical term than that. Specifically because, depending on the orientation of the triangle, it's not always a rise and a run. We literally always compare an opposite side to an adjacent side of the respective right triangle. So because of that, in the mathematical world, we don't use slope ratio. Bye-bye. Technically speaking, mathematically speaking, the comparison inside of a right triangle of any angle of its opposite side compared to its adjacent side has a very specific mathematical name. It's not a slope ratio. It's literally called the tangent ratio. Now, what does that mean for you? Nothing. Not gonna lie. If you actually wanted to take the time to read all of that, all you'd see is that, oh, okay, it's still just opposite over adjacent. Opposite over adjacent. Opposite over adjacent. Hey, the tangent ratio is opposite side length divided by the adjacent length. All of the stuff we've done doesn't change. It's just mathematical nomenclature, how it's referred to. The comparison of an opposite side of an angle's, the opposite side in a right triangle to the adjacent side of a right triangle is just called the tangent ratio. So it's not like anything is we're not reinventing everything. All the stuff we've done will carry over. So that part's kind of cool. But, I'm sure we kind of all recognized and are sick and tired of the 11, 18, 22, and 45 degrees because we use them so much, and we know that there's some specifics. But I think we all kind of recognized, because we did this on our classwork on Monday, is that, yeah, we know those 4 angles, but we did other angles and found out that they have specific slope ratios, isn't it like, doesn't every angle have its own specific slope ratio? I'm sorry, excuse me, tangent ratio? And the answer is, yeah. And as a matter of fact, there are tables out there that will tell you specifically what all of those ratios always are for any specific degree measurement. That's what that is. That is what's called a trigonometric table. And yes, we have been doing trigonometry. Trigonometry, the tri is triangles and ometry is math. We've really, literally just been doing an analyzation of triangle math. That's really all we've been doing. And I know this looks really complicated, but let me direct your attention to, first of all, where it says angle and where it says tan, that's tangent. All this is if you pick a specific angle measure in the left column, you slide down to its corresponding location in the tangent column, and it'll tell you, oh, any angle measure has this tangent ratio. Those are the four we did. You see 11, 18, 22, 45. And there is a specific tangent ratio associated with them. Now, as I make them bigger so that you can all see them, let me be very frank with you. To get us started with learning how to apply and do stuff, if I'm being 100% honest, for 11, 18, and 22 degrees, we rounded. Just to get us started with learning how to apply the math behind it. Technically speaking, an 11-degree angle has a tangent ratio of 0.1944. Yes, that's really close to 0.2. Which is 1/5. It's really close to it. We rounded. 18 degrees is really close to 0.333333 repeating. That's 1/3. 22 degrees, its tangent ratio is almost 0.4 period. It's a little bit bigger. We rounded. We were close enough. The 45 is the 45. That one was fine. We don't have a problem with that. So all of these are legit. There's no real issues. And frankly, if we use any of these three angles, you can use either the memorized one or you can use what is in this table right here. Either of those are fine. I don't really have an issue. But then the question inevitably is like, do I have to memorize all of that? And I'm like, heck no. Heck no. I don't memorize any of that stuff. No. Going forward, what we're going to do is we're going to realize that, okay, give me an angle, and I'll use that tangent ratio that is in the table. Okay, cool. But how do I do that? How do I know, like, oh, I have a 27-degree angle. How do I know what its tangent ratio is? Am I going to have this go to this table every single time? No. You have something that will tell you what tangent ratios are. It's called a calculator. And this is, by the way, why I wanted you to have your calculator today, because I want to make sure you're using it correctly. So, here's my calculator, my scientific calculator that all of you have. Your scientific calculator has a button right there, is mine. It's called tangent button. That's a tangent button. That button right there, I don't know if you've ever pressed it before, but like if you've ever used it and you realize, oh, it gives me some crazy decimal, I bet it's doing some really crazy mathematics inside of it. That's a supercomputer in there. And I'm like, no, not really. You know what that calculator did? That calculator memorized that table right there. That's all it did. It's regurgitating a table. It's not doing crazy math. What is it doing? Well, hey, let me find the tangent ratio of an 11-degree angle, which we know is about 1/5, but apparently according to our table, it's actually slightly smaller. Okay, fine. How does my calculator do that? Well, my calculator, if I put tangent, I press the tangent button, of an 11-degree angle, and by the way, that's how we represent it mathematically, the tangent of an 11-degree angle, tan 11, that's just what it looks like. And I press enter, it tells me, oh, it goes through its internal little workings, and it goes on that table and says, oh, the tangent ratio is 0.19438, blah, 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 keeps going on for days. 0.1944. Hey, look, that's what my table says. Your calculator has this table inside of it. So as long as you know how to work your calculator, you're good. And that's what we're going to start doing going forward. in almost every case. And I'll go through a couple of examples to explain that. So the first thing I need you to do, because you have your calculator with you, because I sent a remind out yesterday, making sure everyone did. What, you're not on the remind account yet? You should probably do that. What I need you all to do is find out and make sure you know how your calculator will show you the tangent ratio of an 11-degree angle is 0.194380309. If you have this calculator, it's simple. You just type it in like you're supposed to. The tangent of an 11-degree, and I press enter. That's cool. That's one way to do it. It's straightforward. There is another way. If you have a phone calculator, and you haven't deleted it, who would delete a calculator app? Like, seriously. If you rotate it, there's your scientific calculator. Some calculators work just as it's written, tangent 11. The scientific calculator on your phone and a couple other ones, you do it backwards. On my phone, I would have to press 11, and then I would have to press the tangent button. By the way, not tan H, that's the hyperbolic tangent. That's a totally different thing. We're not using that. Just tangent. And I press the tangent. And hey, 0.19438, same thing, right? So those are the two most common ways you would enter to find the tangent ratio on your calculator. And that is something you're going to have to be able to do, because come test time, the only thing you're going to have is your calculator. And by the way, not your phone calculator, but whatever. And I'm going to ask you to find tangent ratios of a variety of different angle measures, not just 11, 18, 22, 45. And you're going to have to know how to find them and apply them. And by the way, we'll practice in a little bit, so don't worry about it. But make sure you can find your ratios. For the record, there is one very big hurdle that a lot of times people will get or cannot get over. And that is sometimes, and by the way, if for some reason you're getting a tangent ratio of negative 225, there's a reason for that. In mathematics, there are many ways to calculate, well, pretty much anything. And angle measures are not always calculated in degrees. There are other ways to measure them. Frankly, for the most part, we will do degrees. It's easier to recognize because we're more familiar with that. But there are other angle measures. Other ways to measure those angles. There we go. One of the most common ways, not with degrees, are what are referred to as... Oh, Bella just joined Remind. Good. It's called what's referred to as a radian angle measure. That's what this rad means, if anyone ever knew. If you're in radian mode or rad mode, you're finding the ratios in a different form of degree measurements. And that's not how we want to do it. So down here where it says degrees, that's what DEG means. I will press that to put me into degree mode, and that will make sure that when I do the tangent of 11 degrees, it'll give me the correct actual ratio. If I go back to this calculator, up here where it says DRG, that's where this one is. You'll see I can be in degree mode, radian mode, or this is referred to as gradients. That is another way to measure an angle. It's not what we want to do. We want to be in degree mode, unless explicitly told otherwise. For the rest of math, all right, this isn't true actually. For the rest of this class, we pretty much want to be in degree mode. We will switch eventually. Maybe we'll see. Stay in degree mode. That will be, if there's a problem that comes up, that's typically the one that is the most common. So, okay. Turn that off for the time being. Okay. We're going to start using our calculator. We're going to start solving some problems. Before we go on, are there any questions out there? Anything I can help address? Or are we at the point in time where we just kind of want to practice and go from there? Because that's typically the thing. No one wants to respond. Fine, let's practice then. We'll do it that way. Thank you, Jaden. Thank you, Claire. Thank you for... okay, that's what I thought, but we'll see. Okay, let's practice. So, all right, we're moving on. We recognize that our calculator will tell us how to do stuff. So, let me first acknowledge that I am not going to care specifically if you are given an angle measure, that you know what the tangent ratio is because it's one of the 4 that we memorized. You are still welcome to use that memorized ratio. I don't have a problem with that. So if I saw this problem, I would say, oh, 22 degrees. I know what the tangent ratio of a 22-degree angle is. And by the way, notice I'm calling it the tangent ratio, no, not the slope ratio, because that is what it's actually called. The tangent ratio of a 22-degree angle is 2/5. Sweet. Oh, and I also know that the tangent ratio is always the opposite side divided by the adjacent side inside of a right triangle. So I will say my ratio, 2/5, is equal to opposite over adjacent of this triangle I'm trying to analyze. Okay, here's my angle. The side opposite is x. The side adjacent is 16. I set them equal to each other. Cross multiply across an equal sign. And solve. No problem. Cool. You are allowed to do that for 11, 22, 18, and 45 degrees. You're allowed to use the ratio that you probably have ingrained in your brain for the rest of your life. Sorry. But remember that this was just getting us off the ground floor so that we understood what we were doing. Technically speaking, a 22-degree angle has a slope ratio, tangent ratio of 0.4040. That is more precise, if we're being precise, I guess. Probably the right word. Whatever. Anyway, that's the correct ratio. Like, spot on. I guess it is, well, slightly rounded. Anyway, if you want to, you are also allowed to use the tangent ratio that comes out of your calculator. So if you were to, not that one. That's not right either. Go to your calculator. Tangent of 22 degrees. Cool. 0.404026. We're going to round. If you use that, here's how you would use the tangent ratio as given to you through your calculator. You get in your calculator. Hey, what's the tangent ratio of a 22-degree angle? Boop. Take that ratio and put it over 1. Now, I'm going to be honest, that's not mathematically proper. We don't divide things by 1. It's like multiplying by 1 or saying plus 0. Like, we typically don't do that. But until we get the hang of it, it's probably easier because we are used to using proportions and cross-multiplying across an equal sign. So for the time being, I would take my ratio and put it over 1. That way, when we say, well, okay, the tangent ratio is also opposite over adjacent, it makes our proportion that much easier. So yes, 2/5 is 0.4. This is 0.404. It's slightly different. It's going to give you a slightly different answer, but this is still a proportion. You still cross multiply across an equal sign, and you still solve. You're going to be pretty dang close. As far as any exam, quiz, whatever is concerned, I'm not going to hold you to super precision. If it's in the ballpark, you're going to be fine. So, these are the 2 ways that we're going to approach our problems. Either you know it, or you can always just use your calculator. And frankly, except for those 4 angles, you're going to probably want to get used to using your calculator. So, this is how we're going right now. This is what we're going to do, and we're going to practice a little bit before we break. So, hold on. Questions out there? Anything? Okay. Let's give this a shot then. All right. Before anything else, we're looking. I have a 35-degree angle. I don't know what the tangent ratio of a 35-degree angle is. Good thing my calculator does. I'm looking for A, which is the side opposite. And I know that the adjacent side is 20 feet. Okay. quickly, I want to make sure that everyone gets, what's the tangent ratio of a 35-degree angle? Don't put it in the chat. Just make sure you get a tangent ratio of 35. Make sure your calculator says it's pretty much 0.7. Make sure that's what you get. Tangent ratio 35 degrees, 0.7002075. I'm not caring about sig figs, but I'll round either. Most of the time, I was always taught to round to 3 decimal places. If you round to 2, that's fine. So when we get here, oh, okay, the tangent ratio of a 35-degree angle is 0.700. I make sure to put that over 1 because I want to set it by proportion, because this ratio is also equal to opposite over adjacent. And by the way, this tan 35, that's what we're going to want to get used to. That's how we write it in math. The tangent ratio of a 35-degree angle is equal to opposite over adjacent. The tangent ratio of a 35-degree angle is also equal to whatever comes out of my calculator. So hopefully we get our proportion. We cross multiply. And we solve. Can you show how to set it on the calculator one more time? What do you mean? Like how to find the ratio? Okay, cool. Again, I don't know how your calculator works. Every one of you out there has to know how to use your individual calculator. For me, on this calculator, I do tangent. I press the tangent button, and then I put in my angle degree measure, which in this case was 35. And then you can close the parentheses if you want. And then I press enter, and it pops up for me. So that's what I do. The phone calculator is backwards. I press 35 and then I press tangent. So that's something that we all would have to get used to. Because frankly, I'm just going to be honest, the math of this whole stuff is not the most difficult thing in the world. It's just, hopefully you know how to use your calculator pretty well. And then yes, that is a math teacher saying, use your calculator. Good. Good. So you want us to put the decimal and 2 zeros. Okay, so frankly, Claire, no. If you just put an answer of 4, and yes, by the way, the answer is 14. The answer is 14. I'm just doing it just for the sake of leaving 2 decimals out there. If you just put 14, I would be fine. That's okay. Yeah, I don't have a problem with it. I guess if I wanted to be super specific, I should be saying that at this point in time right here, actually not there. Actually, I should not be using equal signs because a tangent ratio is always, with few exceptions, is irrational, so it goes on forever. So I guess I should be using the approximate sign, but I don't care. If you just put 14, I don't have an issue with that. That's okay. So yeah, that was good. No problem. I'm glad. Megan, good. Sweet. All right. Any other questions? We're going to do a couple more. I want to make sure we do this. I want to make sure we got this. Okay. All right. Let's try one. All right. So I'm going to ask you to solve for x. You have a 76-degree angle, and that side over there is 523. I'm going to give you a minute and a half. What I would like you to do is type your answer into the chat bar, but do not press enter, Jacqueline's. Don't press enter. We'll do a chat explosion when we're all done. So, you have a minute and a half. Go. That's called timing. I'm going to pause as I slowly switch over. Oh, no, you were solving. I was asking everyone to solve for x. Yes. All right. And chat explosion. Everyone's hovering around 130. Cool. Not everyone, though. Thanks, Frankie. That's very precise of you. All right. Well, shoot, I better hope it's right. I mean, hopefully we all found out the tangent ratio of a 76-degree angle is 4.01111, whatever. I put it over 1, and I set it to opposite over adjacent. What's opposite of my 76-degree angle? Opposite's the 523. Adjacent's what I'm solving for. So there's our proportion. We cross multiply. And is it around 130? It sure is. Let's see how accurate Frankie was. Oh, Frankie, you're off by a solid like 12/100ths, man. Come on. Goodness. What are we doing here? So anyway, again, for the record, I'm just going to tell you right now, when it comes to trig, which is what this is right triangle trigonometry. Again, I'm probably going to ask to round it, unless explicitly told otherwise, round to 2 decimals. So all you 130 folk out there, I don't mind right now. It's totally fine. But let's start going to 2 decimal places, please, unless explicitly told otherwise. Nice! That was good. We should stop. No, we're not going to stop. We're going to do one more. Let's see if this was a fluke or not. You're probably in the wrong mode, Gigi. Are you in radian mode? You're probably in radian mode. That's what my guess is. All right, when you do tangent of 76, the tangent ratio of a 76-degree angle, that's probably what's going on. Tell you what, Gigi, in a little bit, we'll take a break. Maybe you can present your screen and show me what you're doing with your calculator, because I can probably figure it out that way, but I can't do it now. But I'm guessing you're in the wrong mode. Yeah, that's what I'm guessing is happening. All right. You know what? Let's do one more, just to prove that's not a fluke. Hold on. Wait. I'm asking everyone to solve for side AC. Okay? You know there's a 9 over there. BC is 9. You know the angle is 41 degrees. Let's see if anyone gets tripped up here. I'm going to give you a minute and a half. We're going to do another chat explosion because I'm just curious what's going to happen here. We'll see. You will have a minute and a half. Angle's 41. This side over here is 9. I want you to solve for AC. You have a minute and a half. Go. I didn't get coffee. That was brilliant. That was 36. All right. I don't know, Miss Maria, what do you think? You think they're going to get it or not?
I think so.
Oh, optimism. That's good.
I believe it.
Oh, okay, good. Optimism. I hope you're right.
Well, you're lagging a little, so if I miss something, that's why.
Sure, that's
Not like
why.
a robot.
Sure.
Okay.
All right. It's been a minute and a half. Let's see. And chat explosion. Ooh, 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 lots of ooh, 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 lots of stuff. Difference. A couple differences. A couple people not doing anything. Far fewer answers here. Jaden, I think you're in the wrong mode. Gigi, you're the outlier. Claire went against the grain with Gigi? It's all right, Jaden. Don't worry about it. Claire is daring. There were just like 6 10.35s, and like Claire's like, nope. My dog cam just fell. Well, let's see. Because I did this one on purpose. Hopefully everyone recognized, well, okay, 41-degree angle. In my calculator, I figured out that my 41-degree angle, the tangent ratio of a 41-degree angle is about 0.869. Here's where the hiccup happened. Tangent ratio is always opposite over adjacent. What's your opposite side? What side is opposite of your angle? If this is my angle, the side that doesn't touch my angle, that's the opposite side. So it means opposite is 9. Adjacent is the side I was trying to solve for. So here's your proportion. Which means when you cross multiply across an equal sign and solve, you get 10.35. Now to the two of you out there that got the 7-ish, you know what you did? You just flipped those. You got those backwards. Your math is fine. Let me reassure you, and that's actually the cool part about this, is that, so to Gigi and Claire out there, no big deal. So we know what happened. So that was Claire and Gigi. So you just switched opposite and adjacent. No worries. If, for the sake of argument, hold on, where's Levi at? Did Levi ask a question that I missed? Is that what happened? Okay, whatever, sorry. Anyway, if you just switched the two for your ratio, okay, that's fine. You did your math just fine. You cross-multiplied and solved just fine. Just the only thing we needed to pay attention to was the fact that it was opposite over adjacent. So that's a mistake I can live with, because we can correct that going forward, and we know what the mistake was. So I don't have a problem with that. That's totally good. For the 10.3 people out there, nice work. Good job. You were able to identify appropriately. I like it. Good job. And even if you didn't, for those 7 point whatever, it's okay. That was just a reversal. For like Megan, that's fine. For like Megan, or I forgot who else also mentioned that they had a calculator bust for whatever reason. We need to figure out what will get your calculator. We need to figure out what gets your calculator correctly, so we can do that in a moment. But yes, otherwise, hopefully we're recognizing, at least I would like to think so, I don't know, that this sure looks like it's not going to be too difficult. At least I hope not.